Hello and welcome to another Math with Miss V video. This one is probability of independent versus dependent events. So in previous videos, we learned how to find the probability of simple and compound events. In this video, we will learn the difference between an independent and dependent events and how to find the probability of each. We are focusing on standard 42 SP8A, where it shows a compound event is a fraction of the outcomes. So an independent event is two or more events in which the outcome of one event does not affect the outcome of other events, such as rolling a standard dice and flipping a coin. The dice does not affect the coin. They are separate or independent events. Next is dependent events. Two or more events in which the outcome of one event affects the outcome of other events. An example would be giving out popsicles from a box. Each popsicle I give out affects the rest of the popsicles in the box and what other people can get. So if I had 10 different flavors of popsicle in the box, the first person would get a 1 in 10 chance of getting a certain flavor. The next person would get a 1 in 9 because I'm going to give the first person their popsicle and they get to keep it. So the second person's popsicle choice is affected by what the first person chooses. They depend on each other. So let's just jump right into some examples. So we're going to start with independent events, and this is very much what we're used to. It was covered in the other videos. We just called it simple probability or compound probability. And so first we have probability of independent events. So we have a coin and we have some marbles in a bag, circles, however you want to look at this. And we want to know the probability for a coin to land on heads and us to randomly choose this yellow circle. And so we treat each one as a simple event. So my coin has two sides. One of them is heads, so I have a 1 in 2 chance of getting heads. For my marbles, I have 6 marbles in the bag. One of them is yellow, so I have a 1 in 6 chance of getting yellow. And the chance of getting both, we multiply and we get a 1 out of 12 chance of getting both heads and the yellow marble. Okay, our next one, the probability of getting tails, is a 1 out of 2. The probability of getting green, we have 2 greens out of 6 marbles, so that's 2 out of 6. We're going to multiply. We get, again, 2 out of 12, which simplifies to 1/6. Okay, so independent probability should be very familiar if you've watched the other videos regarding probability. Now let's look at dependent probability. Okay, so now we're just looking at our marbles, and with dependent, we would keep them. So let's say the probability of getting a red marble and then a green marble if we keep the marble. Okay, so the first time for a red marble, I have 6 marbles in the bag and 2 of them are red. Now with dependent probability, we always assume we get what we want. So I reached into the bag and I got a red marble. And now I'm going to set it to the side. Okay, so setting my red marble to the side, and I'm going to remove it from the bag. We're going to pretend it's not there anymore, which that didn't work very well. Oh, here we go. I'm going to remove it from the bag, and we've set the red marble to the side. And now for our second event, we need to think about what's in the bag. Okay, so I have now 5 marbles in the bag, and 2 of them are green. So we're going to multiply. 2 times 2 is 4. 6 times 5 is 30. I can simplify this. Each one can be divided by 2, and I end up with 2 out of 15. Okay, so dependent assumes whatever you're dealing with, your first event happened and you kept what you were getting. You kept the popsicle, you kept the marble, you kept the sock, you kept the card. So you're assuming what was inside has been kept and will change what is inside your collection of items. So let's reset our bag of marbles. This next one says the probability of getting a green marble and then another green marble. Okay, so looking at our bag, I have 6 marbles, 2 are green. And so I'm going to show I've taken the green marble away, so it's no longer in the bag, and it's sitting off to the side. Okay, so I've taken it out, and now I want to draw another green marble and from the bag. So now I have 5 marbles in my bag, and only one of them is green. So hopefully you noticed that with dependent, as things go on, our denominator decreases because we have fewer items. Okay, so we're going to say 2 times 1 is 2, 6 times 5 is 30. We can reduce to 1 over 15. And we're going to look at one more example. This one won't have any pictures with it, so we'll have to think a little bit more. Okay, so let's assume we have 5 blue socks, 6 green socks, and 7 red socks in a drawer. We want to find the probability of a set of events. So we want to know the probability that if I reach into a drawer, I'll get a red sock and then a green sock. So we're not going to put the socks back. So the probability of the red sock, we have to find out how many socks we have in total. We're going to say 5 plus 6 plus 7, and that gives us 18 socks. So for the first draw, I have 18 socks in my drawer, and I want to know the probability of a red sock, and that is 7. Okay, now we've reached into the drawer, we took a sock out, so we had 18 socks, but we took one away. Now I have 1 in my hand and 1 in the drawer, or the rest are in the drawer, so there's still 17 socks in the drawer. And now I want to think about the probability of getting a green sock. Well, the first sock we took was red, so all of the green socks are still in the drawer. I have 6. Okay, we're going to multiply this. We get 42 over 18 times 17 gives us 306. We can simplify that. And we get 7 over 51. Okay, let's do one more example. So you always assume when you go to the next problem, you've returned everything you've taken out. So all the socks are back in the drawer. We're back to having 18 socks in the drawer. We will know the probability of getting blue. And well, I have 5 blue socks. So on my first event, I reached in the drawer, I grabbed out a sock, it was a blue sock. Now I'm going to reach into the drawer again. Okay, so we had 18 socks in the drawer and we took one out. That gives us 17 socks in the drawer. We want a blue sock again. Well, we had 5 blue socks in the drawer, but we took one out. So now there were 5, we took one away. Now there's 4 blue socks in the drawer. So we're going to end up with 20 over 306. Whoops. So let's simplify that. 20 over 306. And that gives us 10 over 153. Okay, that is probability of independent and dependent events. Be very careful with dependent and remember that you're counting down in your denominator because there's fewer things happening. And your numerator counts down only if you're drawing the same thing twice. Thank you for coming by this Math with Miss V video. I look forward to seeing you in the future.